All right, today we are going to talk about what's called a geometric sequence. So first semester, we did talk about a type of sequence. We talked about what's called arithmetic sequences. So I'm going to put two sequences on the board. One of them is going to be an arithmetic sequence, which we talked about first semester. One's going to be a geometric sequence, which is what we're talking about today. So if one sequence could be 2, 4, 6, 8. And the other one could be 2, 4, 8, 16. Okay, now both of these sequences, there's a pattern. You could find the next term. But what you're looking for is you're trying to identify the pattern and see how you can get from one term to the next. So if I look at that first pattern from 2 to 4, from 4 to 6, from 6 to 8, you would add 2 each time. This is what we call an arithmetic sequence because the terms have what's called a common difference. I apologize for the handwriting. A common difference. I know you're adding, but if you took 4 minus 2, you would get the same thing as if you took 6 minus 4 or 8 minus 6 and so on. Now, if you look at this second sequence over here, to get from 2 to 4, you could add 2, but if you notice, that pattern doesn't stay the same from 4 to 8 and then 8 to 16. The pattern here is multiplying by 2. This, notice, does not have a common difference. If you look at the difference between 2 and 4, that's 2, and the difference between 4 and 8 is 4, and the difference between 8 and 16 is 8. There is no common difference, but there is what we call a common ratio. A common ratio. If a sequence has a common ratio, it is what we call a geometric sequence. A geometric sequence. So let's go ahead and we can just write that sequence down there. 2, 4, 8, 16, and so on. And once again, the reason why it's geometric is because there is a common ratio, which is what we just saw above. Okay, now we do always want to think about a ratio as multiplication, not as division, and we'll talk about a couple examples where if it is divide by 2, how we'll look at that a different way to think of it as multiplication. Now, just like with arithmetic sequences, we have two different ways that we can represent geometric sequences. The first is the same name. It is called a recursive formula. And then we also have what's called an explicit formula. Now, we talked about both of these types of formulas first semester for arithmetic sequences, and the idea is going to be the same. So as a refresher, a recursive formula, so this first one here, it's a lot simpler to write and it's a lot simpler to look at it, and it seems to make more sense looking at it, but it's not as useful because what a recursive formula does, it will say to get this term, you're going to look at the term right before it and multiply by 2. So if 2 is the first term, 4 is the second term, 8 is the third term, 16 is the fourth term. Well, if I want to know the fourth term, I'm going to take the third term, multiply it by 2, there we go. If I want to know the 10th term, I'm going to take the 9th term, multiply it by 2, and there we go. So the recursive formula is pretty straightforward, but it's not really all that useful because if I don't know the term before the term I'm looking for, it doesn't really help me out that much. Now we have some notation that's kind of similar to the arithmetic sequences, but a little different as well. So what we are going to start with, this is called A sub 1. Okay, we can also just call it A. Okay. A sub 1 is what we're going to call the initial condition. Initial condition. Or, in other words, it's just the first term of the sequence. Okay? So, what we want to look at, now this arithmetic sequence, I want to look over here at this geometric sequence that we have over here. If I want to write a recursive formula, okay, so what we wrote down here is we said A of 1 is that initial condition. So for this sequence, A of 1 is 2. A sub 2 is 4. A sub 3 is 8. A sub 4 is 16, and so on. So what I want to do is I want to write how to find the value of any term in the sequence. I want to find A sub n, okay? Now remember, the sub number, that little number down below, that represents the term number. So first term, second term, third term, A sub 1, A sub 2, A sub 3, A sub 4. So if I want to find A sub n, which just means any term at all in the sequence, a recursive formula tells me I need to know the value of the term right before that term. Well, if you think about this, if I want to know the fourth term, I need to know the value of the third term. If I want to find A sub 4, I have to know A sub 3. If I want to know A sub 10, I have to know A sub 9. So if I want to find A sub n, I have to know the value of the term right before A sub n, and this is going to be really similar to the arithmetic sequence. That's going to be A sub n minus 1. This right here, A sub n minus 1, will be the term right before that one. Well, and once I know the value of the term right before it, to get to the next one, which will be A sub n, that's where your common ratio comes in. That's what we found. In this sequence that we already looked at, you multiply by 2. Now, we're not always going to multiply by 2, but we are going to multiply by something. That something we're going to represent as R for common ratio. So, once again, to kind of recap recursive formula, to find the value of any term in the sequence, take the term right before it, multiply by the common ratio. Now, that formula is pretty straightforward, but once again, not super useful. It's going to be more useful to know what is called an explicit formula. And the explicit formula can help you find the value of any term in the sequence. So if we look at our pattern above here, it's going to be easier to develop it. Let's say I wanted to find the third term. Obviously, looking at the sequence, I can tell what it is. But if I didn't know what the third term was, and if I think about how do I get from 2 to 8, kind of looking at my pattern, well, if I start with 2, I multiply by 2 and multiply by 2. Okay? So to know the third term, I started with the first term, and I multiplied by 2, and then I multiplied by 2 again. I multiplied by 2 only 2 times, even though I was looking for the third term. If I want to know the value of the third term, I start with the first term, and I take 2 times 2 times 2. I multiply 2 by itself 3 times, even though I'm looking for the fourth term. Okay, and we'll go over this again when we actually start writing these, but here's what the explicit formula is going to look like. If you want to find A sub n, if you want to find the value of any term in the sequence, you are going to take the value of the first term, once again looking at that up here, you have to start with 2, okay, because yeah, I can see that to get to the third term, I'm going to take times 2 times 2, but you have to start somewhere. You're going to start at the first term. Okay, and then you know you are going to multiply 2 times 2 times 2, but kind of like over here, it's not always going to be 2. Sometimes it may be 3 or 4, or maybe it is a fraction, okay? You are going to multiply by whatever that common ratio is, and you're going to multiply by that common ratio one less time than the term number you're looking for. And once again, the fourth term, how many times did I multiply by 2? 3 times. If I wanted to know the 10th term, I would take 2, and then times 2 times 2 times 2, 9 times, one less time than the one I'm looking for. So let's try some examples. So we are going to determine whether the sequence is geometric, and then we're going to explain. So let's say I have 20, 200, 2,000, 20,000. So the first thing that we probably want to do is we want to figure out what the pattern is. How can I get, and it has to work for every single one of these, from 20 to 200 to 2,000 to 200,000, and hopefully it's jumping out at you that you multiply by 10, okay? Since this is a common ratio, and the key word there is ratio, which means to multiply, okay, or divide, we can say yes, it is geometric, and we might say because it has a common ratio of 10. Okay, what if I have 2, 5, 8, 11, and so on? Well, if I look at the pattern here, to get from 2 to 5, 5 to 8, 8 to 11, we're adding 3. Although that is a sequence, it's not a geometric sequence, because a geometric sequence has a common ratio. And if you're thinking about how to multiply, well, to get from 2 to 5, okay, it's not going to be the same as to multiply to get from 5 to 8. So we could say no, because there is no common ratio. Okay, let's do one more of these. What if I have 5, negative 5, 5, negative 5. Now, if you look at this one, if we think about, well, how could I get from 5 to negative 5, and then negative 5 to 5, and then 5 to negative 5? There's a couple ways. Well, you could think, well, to get from 5 to negative 5, you could subtract 10, or you could multiply by negative 1. Okay, well, then to get from negative 5 to 5, you could add 10, or multiply by negative 1. To get from 5 to negative 5, you'd subtract 10, or multiply by negative 1. So the key word here is that either, if it's a sequence, it needs to have a common ratio or a common difference. Now, although there is a pattern here, it's not the same. Minus 10 plus 10 minus 10. That's not going to work. It's not even a common difference, okay? It does have a common ratio, though. So we would say, yes, it is geometric. Okay, the next ones, we just want to find the common ratio for the sequence. So let's say I have 5, 20, 80, 320. Okay, what we're asking is what would I have to multiply to get from one term to the next? Well, 5 to 20, you multiply by 4. Let's make sure it works for all the other ones. 20 times 4 gives me 80. 80 times 4 gives me 320. So the common ratio, we would say, is 4. Okay, number 5. What if I have 81, 27, 9, 3? Okay, now these are the ones where you have to be careful. Because what you're probably thinking, well, to get from 81 to 27, you divide by 3. To get from 27 to 9, you divide by 3. To get from 9 to 3, you divide by 3. Which isn't wrong, but what we want to do is we want to write it in terms of multiplication. So we don't want to say divide by 3. So what you can do, instead of dividing by 3, the same thing would be to multiply by 1/3. So the common ratio is 1/3. Okay, we don't want to use division. We want to use multiplication. Okay, and number 6, let's say I have 2, negative 6, 18, negative 54. Okay, well, to get from 2 to negative 6, negative 6 to 18, 18 to negative 54, hopefully you're picking this out. If you multiply by negative 3, that would get you to each one. So the common ratio is negative 3. Okay, now let's look at some where we're actually writing some formulas. So we want to write the explicit formula for each geometric sequence. So explicit formula is the key here. So this is where we want to write how you can find any term in the sequence. This is the useful one. Okay, so we're really going to step it out the first one. So let's say we have 3, 6, 12, 24. Okay, so what we're going to do is we're going to develop the explicit formula. So we're going to start here with my first term, which we call a sub 1. Now, a sub 1 is 3, okay? Now, if I wanted to move down and I wanted to talk about a sub 2, now, obviously, a sub 2 is 6. But what we want to talk about is how do I get from a sub 1, which is 3, to 6, okay? Well, I would take 3 and I would multiply it by 2. That would get me to 6, right? Okay, well, if we keep stepping it out, if I want to find a sub 3, okay, which once again I obviously know it's 12, but what I want to do is I want to know if I start with 3, how can I get from 3 to 12? Okay, well, if I start with 3, I would take 3 times 2 times 2 again. I would take 3 times 2 times 2, or 3 times 2 squared. Okay, if I want to find a sub 4, once again, we want to write this starting with 3. How could I get to that 24? Well, you take 3 times 2 times 2 times 2 again. We would take 3 times 2 3 times, which is 3 times 2 cubed, which gives me 24. So what I want to do is I want to write a sub n. How do I find the value of any term in the sequence? Now for this sequence starts at 3. So if you notice, for every single one of these, they all have that 3 because the sequence starts at 3. No matter where you get in your sequence, you're going to have to take 3 times 2 times 2 times 2, how many ever times, depending on what term you're looking for. In this case, I'm looking for a sub n. So I know I'm going to start with 3. And then I'm going to take 3 times 2 times 2 times 2, but I'm going to multiply by 2 one less time than the term number I'm looking for. Notice, if I'm looking for a sub 4, I did 2 cubed. If I'm looking for a sub 3, I did 2 squared. If I need a sub 2, it's 2 to the first. And here, if I wanted to, I could say this could be 3 times 2 to the 0. 1 minus 0 would work. So what this pattern is we start at 3, and then I'm going to multiply by 2 one less time than the term number I'm looking for. That's your explicit formula right there. Okay, let's try another one. Okay, this one says 3, negative 12, 48, negative 192, dot, dot, dot. Okay, so once again, if we start with a sub 1, that first term is 3. Okay, then I want to talk about a sub 2. Now, a sub 2 is negative 12, but starting with 3, how do I get from 3 to negative 12? Well, you'd multiply by negative 4. Okay, now you would have to put that negative 4 in parentheses. That's pretty important. If you don't, it's going to look like a minus 4. That's not the same thing. Okay, to find a sub 3, which in this case is 48, I'd want to know, okay, well, if I start with 3, well, to get from 3 to negative 48, I'd multiply by negative 4 and multiply by negative 4 again. I would take 3 times negative 4 2 times, or 3 times negative 4 squared. If I want to find a sub 4, if I wanted to start with 3 and get all the way to negative 192, I would take 3 times negative 4 times negative 4 times negative 4. I would take 3 times negative 4 3 times, or 3 times negative 4 cubed. So if I want to find the value of any term in the sequence, this sequence you have to start at 3. That's the only way that you're going to get to the other term. And you know you're going to multiply by negative 4, and you're going to multiply by negative 4 one less time than the term number you're looking for. Let's do one more of those. Okay, number 9 says 686, 98, 14, 2, dot, dot, dot. Okay, now this one, if you're looking at the pattern, if you just start with 686 and 98, that might get kind of confusing. But if you keep going here, 98 to 14 and 14 to 2, it looks like we're dividing by 7. And if you check those numbers, that will work. Now, if you remember from number 5, I told you that we don't want to think of this in terms of division. So instead of dividing by 7, we could also say that's the same thing as multiplying by 1/7. That's going to end up being the same thing. So if we try to do this without developing that pattern, if I want to find the value of any term in this sequence, we're going to have to start with that 686. And depending on where I want to go, I'm going to multiply by 1/7, multiply by 1/7, multiply by 1/7. I'm going to multiply by 1/7 one less time than the term number I'm looking for. Okay, and last type of example, we are going to write a recursive formula. So I personally think these are easier to understand and easier to write, even if they're not very useful. So let's say I have 1, 5, 25, 125, dot, dot, dot. So what a recursive formula does, it says, okay, if I want to find the 10th term in the sequence, I need to know the 9th term, okay? Once I know the 9th term, we need to figure out what the pattern is. Well, to get from 1 to 5, 5 to 25, 25 to 125, you're multiplying by 5. So if I want to find the 10th term, I have to know the term right before it, and then I'm going to multiply by 5. If I want to know the 100th term, I have to know the 99th term. And once I know the 99th term, I know I can multiply by 5, and it'll tell me what the 100th term is. So to find the nth term, you have to know the term right before it, which is a sub n minus 1, and you're going to multiply by 5. Now here's the thing. This right here doesn't necessarily define this sequence, because all this tells me to do is take some number and multiply by 5. So what if I start with 2 and I follow this sequence? This would then tell me, well, 2 times 5 is 10, that times 5 is 50, that times 5 is 250. So I followed this rule, but it's not the same as that sequence. So the rule is important, but the rule doesn't mean anything. The rule doesn't help unless you tell me where to start at. So you also have to include a sub 1 equals 1. You have to have both parts, or it's not 100% correct. Let's try 2 more of those. Number 11 says 2, negative 8, 32, negative 64. So if we look at this one, and if I look at this pattern to get from 2 to negative 8, I'd multiply by negative 4, 8 to negative 32, multiply by negative 4, 32 to negative 64. That one's not right. I don't erase that last term. Okay, you'd multiply by negative 4. So to get to each term, you take the term right before it, multiply by negative 4. So once again, we'll kind of step this one out a little bit. If I want to know the, let's say the 15th term, I would need to know the 14th term, and I'd multiply by negative 4. If I want to know the 223rd term, I'd have to know the 222nd term, and then I could multiply by negative 4. So if I want to know the nth term, I have to know the value of the term right before it. And once I do, I'd multiply by negative 4. Okay, now here's the thing. Once again, this is right, but that's not going to tell me how to get that sequence. You have to tell me where to start. You have to say a sub 1 equals 2. Okay, last one. Let's say we have 1 over 125, 1 over 25, 1 over 5, 1, dot, dot, dot. Okay, now fractions can be a little tough, but if you kind of think what's happening here, and you might, if it helps, maybe start later on in the sequence. So if you think about 1/5 to 1, what would you have to multiply by? Well, 1/5 times 5 would get me to 1. Let's make sure that works for all of these. If I take 125 times 5, see how you divide out of 5? And if you take 1 over 25 times 5, see how you divide out of 5? You'd get that answer. Okay, so my pattern here is multiply by 5. So if I want to find the value of any term in the sequence, a sub n, we are going to have to find the value of the term right before the one I'm looking for, and we're going to multiply by 5. But then remember, if you want to get that sequence back, you have to say, well, you have to start at 1 over 125. Have to have both.